at 6, we're going to talk about the product and quotient rules. So remember what we looked at. Power, this kind of ratio that is fixed and very simple and quick, and the sum and difference, and the constant. Power, these two special, very special functions, sum and difference. Power, sum, and difference in two special situations. Okay, now we're going to look at product and quotient. Before we do that, I want to just, not connected to this, I should have done it before, but I don't want to forget. I would like us to differentiate the square root of x. This is another super important formula that we have to remember forever. Okay, so can anyone give us a different form of the square root of x? And again, it comes from exponential rules, and we talked about this rule. So the square root of x. Is there another way? Is there another way of writing the square root of x based on the exponential rules that we looked at a long time ago?
X over 1/2.
X to power 1/2. Awesome. So now this is very easy. Can anyone tell us how to differentiate x to 1/2? Exactly. We discussed this rule last time. It's the power rule. So how do I proceed? X to 1/2. Please try. Anybody, please?
Is it 1/2 x?
Yes, 1/2 x to which power?
Negative 1/2?
Of course, because it's 1/2 minus 1, which was negative 1/2. Excellent. We don't really like to write it like this, but we like to write it like this. Very important. That's another very important rule. So whenever we differentiate the square root of x, we immediately say 1 over 2 the square root of x. So let me summarize it again here. The square root of x prime is 1 over 2 the square root of x. You should have all these formulas on a note card moving forward forever till we finish. Okay, so I'm back to the product. The product rule means two functions multiplied. We didn't see this before. We said we saw the sum and the difference, but not the product. And what is the quotient rule? Same idea, ratio. So we're going to discuss these two, and then we're going to apply them in problems. So these two are specific and very clear and cannot be changed, and you can never try to do anything to them. So f times g prime is f prime times g plus f times g prime. What I like, if you want to twist these around, you can. If you find a different way of writing it, I'm fine with it. I prefer 1 times 2, function 1 times function 2. 1 prime times 2 plus 1 times 2 prime. 1 prime times 2 not differentiated plus 1 not differentiated, but this time 2 differentiated. 1 times 2 prime. 1 prime times 2 plus 1 times 2 prime. Same idea with the ratio, but different, of course. The numerator is this, but with minus. F prime g times fg prime. The denominator is not differentiated, but just squared. Simple and easy to remember. Same, but this one has minus, and it has g squared in the denominator. If you like my 1, 2, 1, 2, then you have 1 over 2 prime, 1 prime times 2 minus 1 times 2 prime over 2 squared. 1 prime times 2, but minus 1 times 2 prime over 2 squared. And now feel free to choose anything, page 162. I'm going to share my screen. We're going to practice these two rules. And then we have one more. Where's my book? Right here. And I wanted 162. So let's start with the product. Okay, anything you want to choose. Yes, of course, these are more sophisticated, but let's start slowly. And then we'll choose the quotient. Anyone would like to choose, or I will? I couldn't hear. I heard something, but I couldn't hear the number.
5.
5, you said. Okay, very good. Let's look at 5. So 5 says g of x equals 4x squared, x to the third, plus 5x. Sorry about that. I forgot to turn off my phone. And I can't turn it off. Sorry. Okay, so you can say, what's the big deal? Just distribute. When you distribute here, you have 4x to the fifth and plus 20x cubed. And differentiate this. Yes, I can. But we want to use the product rule. Say,
Can't see your paper.
oh, of course not. Sorry. Let me start from scratch. So g of x was 4x squared, x cubed plus 5x. And you can say, what's the big deal? Just distribute. And 4, copy the base, add the exponents. 4 times 5 is 20. Copy the base, add the exponents. Yes, and then differentiate. Yes, that is possible. But we want to use the product rule. Why we want to use the product rule? First of all, we want to try to understand it and be able to apply it. And secondly, because this is function 1 and this is function 2. Is it easier this way? Yes, of course, for this problem. But we want to practice the product rule. We will get the same result. So here, let's say if we want to find g prime, can anyone give us g prime so we know what to expect? What is the g prime for this? Anyone would like to help? Oh, I have a chat. I just saw that. I'm not sure what that was. Okay, anyone? Can anyone help, please? Anyone?
20x to the power of 4
Yes, awesome.
plus
Yes,
60x to the square.
that's it. So this is, thank you, Sammy. So this is the result. This is what we expect. Forget about it for a moment. So, but we want to use the product rule. So g prime of x. Can anyone give us the first function prime? So I have to have 1 prime times 2 plus 1 times 2 prime. Can anyone give us the first function differentiated? Just the first function. This.
4x squared.
Very good. You mean 8x times the second one, x to the third plus 5x. This piece is here. This piece is here. I reached plus. I copy the first one, and I have to differentiate the second one and put it here. Can anyone differentiate this for us?
3x squared plus 5.
Excellent. Who was that? Natalie, thank you. So now, when we combine like terms and blah, 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 we have to get this. There is no question about it. They have to be the same. It's the same function. Good, so let's try. So 8x times x to the third is 8x to the fourth. 8x times 5x is 40x squared. 4x squared times 3 is 12x to the fourth. I meant 3x squared. And 4x squared times 5 is positive 20x squared. It better be this. Otherwise, math doesn't make any sense. 8 apples plus 12 apples is 20. And 40 plus 20 must be 60. And again, if you ask, well, why don't you do it like that? Because we wanted to practice the product rule. And the answer has to be the same, of course. That's how the product rule works. I would like us to choose a quotient and then come back to more sophisticated problems. So can anyone choose a problem from the quotient ones? If not, I will. I'll choose 17. And that is f of x equals x to the third plus 27 divided by x plus 3. And let's suppose we do not notice that this is simplifiable. Not like this, like this. No, we have to factor the numerator. But we don't notice that. So we want to use the quotient rule. The first thing we do, we draw a long fraction line and we square the denominator. Do not square this. Do not expand denominators. Don't write x squared plus 6x plus 9 in the denominator. No, it has to stay as is. So now remember what we have to write at the top. Same thing. First prime times 2 minus first times 2 prime. Can anyone give us the numerator prime? And I'll put it here. Differentiate x cubed plus 27 and we'll put it here. Anyone, please? Anyone? Can anyone give us the x cubed plus 27 prime? Please.
I'm not 100% sure, but is it going to be like 3x squared?
That's it. That's it.
Okay.
Times the denominator. Awesome. Minus the numerator times the denominator prime. Can anyone give us the derivative of the denominator? And I'll put it here.
Is it just 1?
Exactly. So I don't have anything to write. Awesome. Thank you, Natalie. Thank you. Good. We continue. It's not done. We have to try to simplify it. Don't try to simplify, please. We will distribute. We will write x plus 3, never to expand because it's in the denominator. And now 3x squared times x. 3x squared times 3 minus x cubed minus 27. 3x cubed minus x cubed, 2x cubed, plus 9x squared minus 27 divided by x plus 3 squared. Any questions? Any questions on this problem? Anyone, please? Okay, so now the floor is open for any type of question, any type of problem, product or quotient from anywhere. Any question? Anyone would like to pick another problem, quotient or product? No one wants, so everyone understood this procedure. No one needs more?
Can we do another quotient?
Yes, please. You want to look at 45?
Yes.
Okay, 45. So 45 is f of x equals 3x squared plus 2x over x squared plus 1. Okay, perfect. Perfect pick. Okay, so this is the quotient rule. Why? It's very clear. It's a quotient of two functions. So then we want f prime of x. The first thing I do, a long fraction line, and square the denominator, but not actually square it. Just leave it alone. This is perfect. You don't have to do anything here. Good. Can anyone differentiate the numerator and tell us what to write? Take a moment and differentiate the numerator. Can anyone help with the derivative of 3x squared plus 2x, please?
X plus 2.
Excellent. We multiply by the denominator. We write minus. We copy the top. We multiply by the denominator prime, and I put it here. Can anyone give us the derivative of the denominator? Anyone, please?
Is it 2x plus 1?
1 prime is always 0.
So then just 2x.
Exactly. Good. So we have to distribute. Don't attempt to simplify. It will not be correct. So 6x times x squared, 6x cubed, 6x times 1, 6x, 2 times x squared, 2x squared, 2 times 1 is 2. Now 2x distributed here with minus in front. 6x to the third minus 4x squared over x squared plus 1 squared. Now we try to simplify if possible in the numerator, see if anything goes away. Yes, these two go away. In descending order always, I have to start with 4x squared plus 2x squared minus 2x squared plus 6x and plus 2. And leave it alone. I would prefer to factor out the negative and 2. 2 is common. So negative 2, x squared minus 3x minus 1 over x squared plus 1 squared. But this is good enough. I'm happy with this, and I'm happy with this. Now, I need to add to the confusion, and thank you so much for saying that. So I said that there are so many different concepts, and I'm going to add one more, and later on I'm going to add one more, so it will be confusing enough. The average rate of change requires 2 points. The instantaneous rate of change or the rate of change, basically they mean f prime of x. But we do have a third one, and we'll have a fourth one later. So that's my page 9. Average cost or profit or revenue. I forgot to look at the video. Okay, so I have to stop that.